In this video, we'll learn some of the basic properties of digital sound. Most of what we'll cover applies to both recording sounds with digital recording devices, as well as playing or editing digital sound files. First, we have file format. This dictates whether sound data gets compressed and in turn contributes to the relative quality and file size of digital audio files. Uncompressed files give the maximum potential for sound quality, but this can make them quite large. Compressed file types fall into two main categories. With lossless compression, all the original audio information is retained in the file. This gives you better quality for things like editing and playback, but the files are still relatively large. Because of this, it might make them more difficult to share over the internet, and they might take up more space on your computer's hard drive, though not quite as much as uncompressed files. With lossy compression, some audio information is permanently removed from a file. This makes the file smaller and easier to share and save, but it may inadvertently cut out important parts of the audio information in a way that's not reversible. Channels set the number of sources within a digital audio file. For example, mono recordings use just one channel. This is a common format for communicating over phone and video calls. Stereo signals use two channels, left and right, while 5.1 surround sound uses 6 channels, 2 left, 2 right, 1 center, and 1 low frequency. Gain sets how sensitive a microphone is during digital recording, and it can affect both the loudness and distortion of captured sounds. We saw some examples of different gain settings in the 2 recording videos for iPhone and Android. Gain is measured in decibels, which is often abbreviated dB for short. The sample rate of digital audio determines the highest pitch that can be recorded or played back. It's measured in hertz or cycles per second. For some examples of sample rate, let's check out this video.
Let's listen to a few recordings made at different sample rates. Pay special attention to the changes in high-frequency content of each. As the sample rate decreases, the high-frequency information is less. First, a recording made at 44,100 samples per second, or 44.1 kilohertz, the standard rate used for delivering music to consumers. Next is the same recording made at 1/2 that rate, or 22.050 kilohertz. Last is the same recording made at 11.025 kilohertz.
The bit depth of digital audio dictates the range of quiet and loud sounds that can be captured in a recording or played back from a file. So the lower the bit depth, the smaller that range of loud to quiet. Lower bit depth recordings will also have more noise relative to the amount of signal, which is usually the part of the sound that you're interested in recording. Bit depth is measured in binary digits, and a bit depth of 16 to 24 is generally recommended for recording. And here we'll see some examples of how bit depth works.
First, a recording made with 16 bits per sample.
Only time will tell our story. Try to hold it as it slips away. Take your half-forgotten glory. Save it for...
Now, a recording made with 8 bits.
Only time will tell our story. Try to hold it it slips away. Take your hat.
And now, using only 4 bits. At a resolution of 4 bits, the noise actually covers up some of the music in the quiet sections.
Okay, that's an overview of some basic properties of digital sound.